Hello students. So last class we have studied about the chemical properties of ether where cleavage of CO bond takes place. Now let us discuss the other chemical properties of ether. Among them, one, reaction due to ethereal oxygen. So you know ether has structure like this. So here oxygen atom has two lone pair of electron. In this way it can form these electron rich species. It can form compounds with electron deficient species. So it forms complexes with Grignard's reagent with electron deficient species like boron trifluoride, aluminum chloride, ferric chloride, etc. So first, formation of complexes. So diethyl ether plus boron trifluoride, it forms complexes with this coordinate bond. This is electron deficient species, this is electron rich species. So diethyl ether, and this is your boron trifluoroetherate. Boron trifluoroetherate. Similar way it reacts with aluminum chloride and ferric chloride. Then reaction with Grignard's reagent. So Grignard's reagent, alkyl magnesium halide. Suppose I have taken here R MgX, known as alkyl magnesium halide. It reacts with Grignard's reagent to form complexes magnesium. So here halogen, here alkyl group, and coordinate bond by ether. So it forms coordinate bond by ether and two covalent bond with alkyl group and halogens. So in this way it acts as a complex and it is also used as a solvent in various organic reactions. Next, formation of oxonium salts. Formation of oxonium salts. So ether reacts with concentrated hydrochloric acid or concentrated sulfuric acid in cold condition to form corresponding oxonium salt. Ether reacts with concentrated hydrochloric acid and concentrated sulfuric acid in cold or in low temperature to form corresponding oxonium salt. Look at the equation. Diethyl ether reacts with hydrochloric acid concentrated in cold condition to form H plus Cl minus diethyl oxonium chloride. So ether reacts with concentrated hydrochloric acid in cold condition to form diethyl oxonium chloride. Similarly, it reacts with concentrated sulfuric acid to form diethyl oxonium hydrogen sulfate. diethyl oxonium hydrogen sulfate. So ether reacts with sulfuric acid, concentrated sulfuric acid in cold condition to form diethyl oxonium hydrogen sulfate. Next come to another reaction, that is reaction due to alkyl group. Reactions involving these alkyl groups. Reactions involving alkyl groups. So, when ether undergo oxidation, actually ether do not undergo oxidation in presence of various strong oxidizing agents like potassium dichromate, potassium permanganate, etc. But when it exposed to light or light and air, when it exposed to light and air, it undergoes slightly oxidation to form peroxides, to form some extent of peroxides. So, aerial oxidation. So, ether when undergo oxidation, O2, air, that is from air, okay, in presence of light, it undergo oxidation to form peroxides. So, diethyl ether, I can write like this. Here it undergo oxidation to form peroxide. So we can say peroxides of diethyl ether. Ether when undergo aerial oxidation in presence of light, it forms to some extent it forms peroxides. Okay, to some extent it forms peroxides. But when it undergoes combustion, it forms carbon dioxide and water. Combustion gives rise to ether when undergo combustion, it forms carbon dioxide and water. Next, reactions. Next, halogenation. So, ethers when reacts with chlorine or bromine in dark, ether when reacts with chlorine or bromine in dark, then one halogen atom from alpha carbon is substituted by halogens. And this is a stepwise reaction. So first one from one side of alkyl group, another hydrogen is from another side. Okay. Look at the equation. In dark, it forms ClO, CH2, CH3, alpha chloro diethyl ether or 1-chloro diethyl ether. This is diethyl ether, and when again it reacts with chlorine in dark, minus HCl it forms alpha dash dichloro diethyl ether. So diethyl ether, when reacts with chlorine in dark, the alpha hydrogen atoms are replaced by chlorine to form alpha dash dichloro diethyl ether, or we can say 1 dash dichloro diethyl ether. 1 dash dichloro diethyl ether or alpha dash dichloro diethyl ether. But if the reaction takes place in excess of chlorine in presence of light, then all the hydrogen atoms are replaced by chlorine atoms. Look at the equation. Plus, in presence of light, perchloro diethyl ether. So if diethyl ether reacts with chlorine in excess, in presence of light, then all the hydrogen atoms are replaced by chlorine and it forms perchloro diethyl ether. Okay. Now let us discuss another chemical property, that is electrophilic substitution reaction. In anisole. So anisole, you know, that is your methoxybenzene. So this is your anisole. It has 2 lone pair of electron. As it has a lone pair of electron, due to plus R effect, resonance effect, or we can say mesomeric effect, due to resonance plus R effect and plus M effect, there is electron density. That electron density increases at ortho and para position. You know the resonance structure. So this bond comes here, this comes here, and this bond comes here, this bond comes here. In this at ortho position and para position, the electron density increases. As a result, an electrophile is substituted or preferred to substitute at ortho and para position. So this is your ortho-para directing and ring activating group. So methoxy group is ortho-para directing and ring activating group. In this way, electrophilic substitution of anisole takes place at ortho and para position. Let us consider or discuss some reactions. First, halogenation. So this is anisole. Or we can say methoxybenzene. When it reacts with bromine in presence of acetic acid. Anisole, when reacts with bromine in presence of acetic acid, it forms a mixture of orthobromoanisole and para-bromoanisole. But the para-bromoanisole is the major product. About 90% of para form is formed and 10% ortho form is formed. So it forms a mixture of this is orthobromoanisole and this is para-bromoanisole. So anisole reacts with bromine to form orthobromoanisole and para-bromoanisole in presence of acetic acid. Para product is more than that of ortho. Similarly, when it undergo nitration, the reaction mixture is concentrated nitric acid and concentrated sulfuric acid. When it undergo nitration, it forms orthonitroanisole and para-nitroanisole. Para product is the major product. So it forms para-nitroanisole and orthonitroanisole or methoxybenzene. Orthonitromethoxybenzene, para-nitromethoxybenzene also you can say. So anisole when reacts with bromine, it forms orthobromoanisole, para-bromoanisole. When it reacts with mixture of concentrated nitric acid and concentrated sulfuric acid, it forms orthonitroanisole and para-nitroanisole. And again, similarly it reacts with concentrated sulfuric acid. It undergoes sulfonation to form minus H2O that is your orthomethoxybenzene sulfonic acid and this is your para-methoxybenzene sulfonic acid. So when anisole treated with concentrated sulfuric acid, it forms orthomethoxybenzene sulfonic acid and para-methoxybenzene sulfonic acid. Anisole also undergoes Friedel-Crafts reaction. It reacts with methyl chloride in presence of AlCl3 and acetyl chloride in presence of AlCl3. Next come to Friedel-Crafts reaction. So anisole reacts with methyl chloride in presence of anhydrous aluminum chloride to form orthomethoxytoluene plus para-methoxytoluene. So this is your orthomethoxytoluene, para-methoxytoluene. So anisole or methoxybenzene reacts with methyl chloride in presence of anhydrous aluminum chloride to form orthomethoxytoluene and para-methoxytoluene. Similarly, it reacts with acetyl chloride in presence of anhydrous aluminum chloride to form orthomethoxyacetophenone So anisole reacts with acetyl chloride in presence of anhydrous aluminum chloride to form orthomethoxyacetophenone and para-methoxyacetophenone. So it reacts with acetyl chloride or ethanol chloride in presence of anhydrous aluminum chloride to form orthomethoxyacetophenone and para-methoxyacetophenone. So these are all the chemical properties of ether. Next, uses of ether. So ethers are used as solvents in various organic reactions. It is used as a medium for Grignard's reagent. It is used as anesthetic. It is used for the extraction of various organic